Have your attention, please. Week 7, third part of complex numbers. Tonight, we will be looking at something called the complex conjugate of a complex number. We're going to look at, we need to know about that to be able to do division of rectangular complex numbers. Okay, so I'm going to go through that, and then I'm going to issue assignment 2, which is the assignment on, you guessed it, complex numbers. There'll be one more bit of teaching next week around some practical uses of complex numbers, because the M, as you'll see in a little while when we look at it, the M part, merit part of the assignment is around you calculating an electrical circuit, parallel impedances involving complex numbers. So that we'll use techniques tonight, but then we'll just go through that again and apply it to a couple of real world problems next week. Okay? So, drill questions for this week. Based on what we done last week. Easy, Weller? Okay. Who said easy?
I got 96.
So tell me how you got 96 then. You multiply these magnitudes together, and then the angle is 39 degrees because we add the angles. Yeah. Second one. Mr. Connolly on the end there, that's full of it. Tell me how you done the second one. 3 times 7, 21. Angle 98 minus 98, 0 degrees. Okay? I'll write these answers here. So that one's 96, angle 39 degrees. That one is 21, angle 0 degrees. So if the angles are equal and opposite, they cancel and you end up with no angle. Right? This one.
17 times 4.
17 times 4 is 68. Angle minus 35 degrees. Agreed. Yeah. Josh, this one. Tell me how you're doing it.
I use what the class is the graph.
Oh, yeah, I see. Yeah.
Times each brackets.
So tell me what you got then.
Well, I've done 2 times 3 first.
2 times 3 is 6.
And 2 times 4j.
2 times
4j. Minus 4j.
minus 8j together, yeah.
And plus 3j times 3.
3j times 3 is plus 9j. Can we have less chat up the back there, please? Pay this man some respect and listen. Right.
And I've done plus 3j times the minus 4j minus 12j squared.
Minus 12j squared. Phil, do you get that? Do you see what's going on there? Because you weren't here last week. Multiplied each, so it's the same as multiplying out any other set of brackets. Okay? Now, tell us what happens with the j squared.
Minus 12 times 5 minus 1.
Minus 1, yeah. So the j squared term, j squared disappears. So what it becomes is 6 minus 8j plus 9j plus 12, because the j squared changes the sign of that last coefficient. Yeah?
Then I added the 6 and the 12 together.
6 and the 12 together to make 18.
And then I added minus 9.
Minus 8 and the plus 9. So it's 18 plus j. Am I right?
17.
Minus 8
Yeah.
plus 9
Yeah, that was
is 1j. Agreed?
Yeah.
Everyone agreed? Everyone agree with that, yeah? Right, the last two. Give me the final answers, someone. 52 and 60.
I got 68. Well done, buddy.
So is it 60 or is it 68? Let's just go, listen, quiet please, go through this one. 8 8s are 64. 8 times 2j is plus 16j. Minus 2 times 8 is minus 16j. Minus 2 times 2 is minus 4j squared. Okay? These two cancel each other out. That's equal to minus 1, so the sign of that changes to plus 4. So we end up with 64 plus 4 equals 68. Okay? So those last two, listen, those last two had us losing the j term once we've multiplied them out. And there's a special name for that technique, and it's useful when we want to divide two complex numbers. Helps us to simplify and actually do that arithmetic. So, moving on to formalise that. The complex conjugate of a complex number. Complex conjugate of a rectangular number is a complex number that has had the sign of the imaginary part changed. Nothing else changes. So if you look back at those last two, and they're exactly the same ones, 6 plus j, 4j. The complex conjugate of that is 6 minus 4j. 8 minus 2j, the complex conjugate is 8 plus 2j. So these two are complex conjugates of those two, and vice versa. Okay? You've already seen that if you multiply a complex number by its complex conjugate, because those last two were that, you actually get a result that's just a real number, a constant. Your results were 50 something and 68, the last one, weren't it? Just a constant. You're always going to cancel out and get rid of the imaginary part of the complex number if you multiply by the complex conjugate, always. And in fact, you could formalise that. You may not have noticed, but the result is always just the two coefficients squared and added together. If we go back to that last example we went through, the answer is always 8 squared plus 2 squared. Whatever those two numbers are, you just square them and add them together, and you've got the answer. Okay? But the idea is you see what happens first, and then you realise there's a common element to it, and that always happens. Alright? So, add the two coefficients together. In this example, we got 2 and 2, 2 squared and 2 squared, add up to 8. 4 and 4 is 8. This example, we got 3 and 4. 3 and 4, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. The two answers are there with the full work solution, and you can see where it comes from by just squaring the two coefficients. Okay? So, on to division of Cartesian or rectangular complex numbers. This is achieved by the technique of multiplying the numerator and the denominator of the fraction by the complex conjugate to remove the imaginary part from the denominator. So I'm going to go through this one step by step and then give you some to do. And I'm also going to give you the assignment based around this, so you'll also today be able to make a start on that, and I'm going to feed back your other work and so on. Okay? So let's have a look at this example. We've got 2 minus 5j divided by 3 plus 4j. The technique here is involving, if we know that if I multiply the bottom by 3 minus 4j, I will remove the j part from the denominator. But if I divide the bottom of the fraction by that, multiply the bottom by the complex conjugate, I also have to multiply the top to make it the same. What I do to the bottom, I must also do to the top. Yeah? We know how to do the bottom line here easily, don't we? That is... No, whoa, you can't do it to the top.
Sorry.
Only the bottom. 3 squared plus 4 squared. Okay, we'll leave it like that for now. That's what we know that is. Okay, what about the top? Yeah, you have to multiply the top one out in the normal way, right? So 2 times 3 is 6. 2 times minus 4j is minus 8j. Minus 5j times 3 is minus 15j. And minus 5j times minus 4j minus 20j squared. Okay? I'm going to be expecting when you have to do this in your assignments to lay out like this, so you show the steps that you're using. Right? Now we can simplify. We've got 6 minus 8 minus 15 is minus 23j. And what happens here? It becomes a plus 20. And that will be all over 3 3s are 9, 4 4s are 16, all over 25. Everybody happy with that? Yeah? It's not the end, no. 2 constants come together. 6, 26, minus 23j over 25. Okay, you should really simplify. You can write that one of 2 ways. You can write it as 26 over 25 minus 23 over 25j, if you want to write it in fractions. Or you can divide 26 by 25 and put the result. Someone push the buttons, please. 26 by 25, 1.04, 20 minus 23 over 25 is 0.92j. Where? It was minus 20. What is j squared to it? Yeah? Minus 20 times minus 1 is?
Minus 5j plus minus 4j plus 20.
Well done, Noel. Plus 20. Well done. Spotted my deliberate mistake. Someone else told me you're right there. No. Well done. We all make mistakes, don't we? Just goes to show how easy it is, right? So that's plus 20, meaning this is minus 20. Yep, there. And that follows through. That's 6 minus 20. I'll go through it again. 6 minus 20 is minus 14. So minus 14 over 25 is?
Minus 0.56.
The funny thing is I got a work done, so I could have held in my hand, but I didn't bother. Okay. So, for those that find it a little more difficult perhaps to follow that in at that speed, I will just go through it once more. Right. First of all, we've got a quotient or a fraction of two complex numbers. The first thing we do is multiply the top and the bottom by the complex conjugate of the denominator. So that is 3 plus 4, so we multiply it by 3 minus 4j. And we have to, what we do with the bottom, we also have to do with the top. That's basic algebra. If we want to multiply the bottom by a particular number, that's okay, as long as we also multiply all of the top by that number. We've still got the same fraction, we've still got balance. Okay? Then what we do is we know that means if we multiply a number by its own complex conjugate, we just square the two coefficients. So we end up with 3 squared and 4 squared on the bottom here. Then the top line, we do 2 times 3, 6. We do 2 times minus 4j, minus 8j. We do minus 5 times 3 is minus 15j. And we do minus 5 times minus 4, which is plus 20j. On the end there. J squared, sorry. That's the magic pen. The idea is anyone watching the video can see it and then it disappears afterwards. Right? So multiplying the bottom out, I end up with 25 as the denominator. 3 squared plus 4 squared is 25. Here I've brought the two j terms together. 8 minus 15 is minus 23. The j squared here changes the sign of the constant, so that becomes minus 20. 6 minus 20 is minus 14. Minus 23j over 25. We can split that into fractions, and that'll be exact. Or, if you so wish, you can turn it into decimals, and you will round it and have inaccuracy. Alright? What you should be thinking about is, and I noticed from some of the other assignments I've marked so far, there's 1 or 2 people using lots and lots of decimal places, lots of significant figures. 3 to 4 significant figures for the work I'm giving you is usually around the appropriate thing to do for decimal numbers. Okay? You should also be thinking about, in some cases, being comfortable with leaving something in fractional form. Alright? If you give me that answer, or that answer, to an assignment question, you'll get the mark. Alright?
As a fraction, like you said, it's minus 37, that's 25j.
Where did you get minus 37 from? You can't combine those two together, because that's a real part and that's an imaginary part. They have to stay separate. So you can't, although you're showing them as a fraction, you can't add them together. And you can't, just because they're over 25, if you do that, you're ignoring the j. And you can't do that. So those two parts must remain separate, because this is your real part, a number, yeah, but this is the imaginary part. And remember what we're talking about. We're talking about a vector that goes from 0 there, minus 14 over 25 in that direction, yeah, and 23 over 25 up. Oh no, negative on the y-axis as well. So we go in negative down here. I'm on a magic pen still, aren't I? And then that's a vector that sits in there. Right, so you can't combine those two parts. You must try and get that in your head, that they can't be combined. Okay? I can indeed. Where? There?